Good morning, students. Today we'll be learning about thrust and pressure. We have already learned about force and its SI unit as Newton. Now we'll be knowing what is the difference between force and thrust. Thrust is also a kind of force that acts on a surface in a perpendicular direction. In the slide, two pictures are given. In the first one, you can see one circular area shown on horizontal plane, and the direction of force is shown with an arrow with blue color, and the direction of force is perpendicular to the plane of the area. Similarly, in the second figure, the area is shown with a blue square and the direction of force is shown with a black arrow. Here also the direction of force is perpendicular to the blue surface. So whatever be the orientation of the plane, the force has to be perpendicular to it, and then that force is known as thrust. As thrust is also a kind of force, SI unit of thrust is Newton. What is pressure? Pressure is the thrust per unit area, or we can say that pressure is equal to force by area or thrust by area on which it acts. SI unit of pressure is Pascal. It can also be written as capital P small a. Now, how will you define 1 Pascal? As we know, the formula for pressure is force by area. So, we can simply write down the SI unit, corresponding SI units. Instead of pressure, we are writing Pascal. Instead of force, we are writing Newton. And instead of area, we are writing meter square. Now, this equation we can write in a simple sentence. 1 Pascal is defined as the amount of pressure generated when a force of 1 Newton is exerted on an area of 1 square meter. Now we'll be knowing the relationship between force and pressure by a simple activity. The materials what we need for this one, that is, I think it is available with you all. You can try it now. We need a deep tray. If you don't have a deep tray, you can take a flat plate also. Refined flour or wheat also you can use. Glass rod and 4 to 5 glass slabs. First we are filling the tray with refined flour and we are stirring the glass rod to spread out the flour so that a uniform flour bed is created in the tray. Now we are placing the rectangular glass slab with 3 different faces on the flour one by one, and the observation is recorded. Now what we are actually seeing, we'll be seeing that when the rectangular glass slab is placed on the maximum dimension in contact with the flour, how is the depression, and when it is placed with minimum dimension kept in contact with the flour, what is the change in depression? At all, is there any change or not? Now we are keeping the slab on its maximum dimension in contact with the flour. Then we are arranging 3 of the slabs, one on top of the other, on the first slab, and again the observation is recorded. So we'll see when we are increasing the load on it, that means we are increasing the downward force due to weight, is the depression in flour increasing or it remains the same or it is decreasing. So these observations will be noting, and after that, in conclusion, there are certain fill in the blanks given. We have to answer this after doing this activity. Why do load carrying heavy vehicles have many wheels. All these application-based questions based on the concept of pressure and force, this has to be answered using this equation: pressure is equal to force by area. So greater the area of contact between the two surfaces, lesser will be the pressure. So heavy vehicles have large number of wheels so that the area of contact increases. So the force exerted due to the weight of heavy load, it is distributed over larger area, and the effect of pressure on the tire and the ground is less. Similarly, why can we cut fruits easily with a sharp knife, not with a blunt one? Here also we are applying the same concept: pressure is equal to force by area. So for a sharp knife, the area of contact between the knife and the fruit is very less, and that is why the force we are applying for cutting the fruit, that is distributed over a very small area. So the effect of pressure on the vegetable is quite high, so that it can be cut very easily. For a blunt knife, the area increases, so the pressure is decreased. Why is the tip of needle sharp? And this same concept we can use for office pins, safety pins, or any piercing device like needle. Here also pressure is equal to force by area, and for a sharp pointed instrument, the area of contact is very small. So the pressure we are applying for piercing, that is getting distributed over a very small area, leaving a large amount of pressure on the surface of cloth or paper or whatever. So it can be easily pierced through. Here are few more examples of the same. We have noticed that the bottom of the football shoes consist of spikes, and the sharp spikes reduce the area of contact between the shoe and the field. And automatically what happens, as because pressure is equal to force by area, so when the area of contact is reduced, automatically the effect of pressure is more on the track. This will provide the runner a better grip on the ground. In the second figure, we can see a boy digging a hole with a spade. The edge of the spade is kept sharp, so the surface area of contact is very small. So force exerted by the boy for digging, that is being distributed over a very small area, so the effect of pressure is very high and his work is being easier here. This is a very common example that why there is a wide shoulder pad attached to a heavy school bag, because when we are attaching this wide pad in the heavy school bag, automatically the area of contact increases, and the force due to the weight of the bag and the books and notebooks inside, that is distributed over a larger area, and the effect of pressure on the shoulder is less. In animal kingdom also, we have seen that elephants have broad soles to reduce the pressure exerted on the ground. Area of contact is more, so the weight is being distributed over a larger area. Similarly, polar bears have wide paws so that they do not sink too deeply into the soft snowy ground due to their heavy weights. Why is it easier to walk on soft sand if we have flat shoes rather than shoes with sharp heels? We know pressure is equal to force by area. So greater the area of contact between the two surfaces, lesser will be the pressure. So for a flat shoe, as we can see in the figure, the area of contact is large. And so the force due to the weight of the man that is being distributed over a larger area, and so the effect of pressure on ground is less than in case of a pointed heel shoe. Similarly, we can see that wooden or concrete sleepers are kept below the railway line. Same concept is being applied here. When we are placing wooden or concrete sleepers, the area of contact of the rail and the ground increases because these sleepers are tightly attached to the railway lines. So total area of contact increases. So the force which is exerted due to the weight of the train that is distributed over a larger area, and the effect of pressure on ground is less. We can see that the foundations of buildings and dams are made wide. As pressure is equal to force by area, greater the area of contact between the two surfaces, lesser will be the pressure. So to withstand the heavy weight and the force created due to the heavy weight of buildings and dams, the foundations are made wide so that the effect of pressure on ground is less. So the possibility of sinking is less. Here are some numerical problems on force and pressure. Calculate the pressure when a force of 200 Newton is exerted on an area of 5 meters square. Let us note down the given data along with the symbol and the SI unit. Force, which is denoted by capital F, that is equal to 200 Newton according to the problem. Area A is equal to 5 meters square. Pressure is equal to force by area. So we can replace the values as 200 Newton by 5 meters square. So pressure is equal to 40 Pascal. SI unit of pressure is Pascal. In the second sum, we need to find out the force acting on an area of 0.5 meters square, which will produce a pressure of 500 Pascal. Here pressure P is provided and area A is 0.5 meters square. As we know, pressure is equal to force by area. If we cross multiply, we will be getting force is equal to pressure into area. So force is equal to 500 into 0.5. Force is equal to 250 Newton. We will be solving question number 3. A force of 150 Newton acts on a surface of area 15 centimeters square. Calculate the thrust and pressure. No, I think all of you have noticed that the force is given in SI unit and the area is given in CGS unit. So we need to convert. Let us write down the given data. Thrust F is equal to 150 Newton and surface area is 15 centimeters square. Now this conversion between centimeter square and meter square, we need to learn that how we are doing it. We know that 100 centimeter is equal to 1 meter. So 1 centimeter is equal to 1 by 100 meter. Okay. And 1 centimeter square is equal to 1 centimeter into 1 centimeter. So 1 centimeter means 1 by 100 meter into 1 by 100 meter. So 1 centimeter square is equal to 1 by 10,000 meter square. The surface area given in the question is 15 centimeter square, that is equal to 15 by 10,000 meter square or 15 into 10 to the power minus 4 meter square. Now we know the formula pressure is equal to thrust by area. So we are replacing the values, that is 150 by 15 into 10 to the power minus 4, and we are getting that pressure is equal to 1 lakh Pascal. We'll solve question number 4. If two forces in the ratio 5:7 act on two areas in the ratio 4:5, find the ratio of pressure exerted. So ratio of forces or thrust are 5:7. Let the common factor be x. Forces are 5x and 7x. The ratio of areas is 4:5 and the common factor we are taking as y. So areas will be 4y and 5y. We know the formula for pressure is thrust by area. So P1 is equal to F1 by A1, that means 5x by 7y. Similarly, P2 is equal to F2 by A2, that is 4x by 5y. So we are finding the ratio of pressure exerted by dividing P1 by P2. So 5x by 7y divided by 4x by 5y. We are changing the sign, division sign to multiplication sign and taking the reciprocal. 5x by 4y into 5y by 4x. It is becoming, after simplification, 25:28. Question number 5. The element weighs 20,000 newtons, stands on 1 foot of area 1000 centimeters square. How much pressure would it exert on the ground? Force applied by elephant is 20,000 newton. It is given in SI unit. Area is 1000 centimeters square. So we are converting it to meter square by dividing by 10,000. So 1000 by 100 into 100, we are getting 0.1 meter square. Pressure is given by, pressure is equal to force by area. So 20,000 by 0.1, that is 2 lakhs Newton per meter square. That means 2 lakhs Pascal. Newton per meter square is Pascal. That is the SI unit of pressure. Now we are moving to question number 6. Foot of an elephant has an area 275 centimeters square. If the mass of an elephant is 2200 kg, then find the pressure exerted by the elephant on ground. Look at the sum here. Force or thrust on ground is not provided. They have provided you with mass of elephant, that is 2200 kg. So we have to convert it into weight. You know that weight is equal to m into g, mass into acceleration due to gravity. So 2200 into 10 meter per second square. So we are getting 22,000 Newton. That is the thrust on ground. And area of a foot is 275 centimeters square, that is divided by 10,000 to convert it into meter square. And how many feet an elephant has? It has 4 feet. So area of 4 feet will be 275 into 4 divided by 10,000 meters square. You can reduce it. You will be getting 11 by 100 meters square. Pressure is given by force by area. So 22,000 divided by 11 by 100. So the final answer we are getting is 2 lakhs Pascal. 2 lakhs Pascal here also we are getting. So you need to understand, when the area is given in centimeter square, we have to convert it into meter square by dividing by 10,000. And if mass is provided, we have to convert it into weight, because weight is the amount of force by which earth is attracting an object. So that is the amount of thrust also on ground. So by using the formula W is equal to mg, we have to do this conversion. In the figure we can see an object is placed on its broader face, and in the second figure the same object is placed on its smaller face. In which case the pressure exerted by the object is more and why? The same concept is being used here. Pressure is equal to force by area. So in the first figure we can see the object is placed on its broader face, and we have seen the activity we have done also. There also we have noticed that whenever the area of contact is more, the depression is less. That means the effect of pressure is less. So more area of contact, the force due to the weight of the object is distributed over a larger area. So the effect of pressure will be less than in the second case. One brick is kept in three different ways on a table as shown in the figure. At which position the pressure exerted by the brick will be maximum? There are three positions A, B and C shown here. As pressure is equal to force by area, we can easily find out that in position A it will be maximum, because in position A the brick is kept on its smallest surface touching the ground. So area of contact being less, the effect of pressure will be highest in case A.